Right, Hashem is putting some boxes into small vans and into large vans. He puts 5 boxes into each small van. Okay, so here's my small van. Here it is. Here's my little van. And it's got 5 boxes in it. My large van is bigger. And in fact, because it's 25, I can see that it's going to be 1, 2, 3, 4, 5 bigger. Okay, so that's my small van, that's my large van. We've done this. He puts a total of 400 boxes into the vans so that the number of small boxes in small vans to the number of boxes in large vans is 3 to 5. Okay, so here's my small vans to large vans. Well, I've got 1 to 5, so clearly I need 3 small vans for 1 large van. And now I've got my 3 to 5. And I can see that that is 40 boxes. Okay. Oh, but it says I've got 400 boxes. That's easy. Look, 40 times 10 is 400. So I'm going to times this by 10 and times this by 10. No, maybe not times that by 10. So now I've got 150 boxes in small vans and 250 boxes in large vans, which is 400 boxes altogether. I've got 30 small vans and 10 large vans. Okay, so I've used up all this top bit of information. Hashem says less than 30% of the vans filled with boxes are large vans. Well, let's see, we've got 10 large vans out of 40 vans altogether, which is 25%. Is 25% less than 30%? Yes, he is correct. And again, you must show all your working. Okay, complete the table of values for y minus x cubed. So, my first x is minus 2. So I'm going to write y equals 3 minus 2 cubed. Remember brackets for your negatives. Now you could do it on your calculator and you'll get 3 plus 8 equals 11. So you've got 11 in here. Then your next one, y equals 3 minus 0 cubed. Well, that's just 3 minus 0, so it's 3. So y equals 3 here. Your next one, your x is worth 1. So you're going to write y equals 3 minus 1 cubed, which is y equals 3 minus 1, y equals 2. And your last one, y equals 3 minus 2 cubed, which is going to give you y equals 3 minus 8, y equals minus 5. Now, even if you fill these in incorrectly, you can get marks if you plot what you have filled in onto the graph. So I've got minus 2, 11, minus 1, 4, 0, 3, 1, 2, and 2, minus 5. And we're going to join it up with as smooth a line as we can, going through all my points. And there is my graph. X cubed graphs look a bit like a wiggly snake. Okay. I have now got a right angle triangle. I've got an angle. So I can say straight away, I'm going to be looking at doing trigonometry. So I can have a look and I'm going to label my triangle up. So my side opposite the right angle is always the hypotenuse. Then going across from this angle, this is my opposite. So I have opposite and hypotenuse, which means I know I am going to use the formula sine theta equals opposite divided by hypotenuse. I'm going to substitute sine and theta. My angle is 37. The opposite is x. The hypotenuse is 534. So I've got x divided by 534. I'm going to do my opposites. So I've got 534 times sine 37. Into my calculator. So once I put it into my calculator, I get x equals 321.369222236. The answer has to be correct to one decimal place. When you've got a question like this, it's always a good idea to write down your whole calculator answer and then underneath do the rounding. So 321.4. (3a) take away 2b. Looks like it's going to be really complicated because we've got these column vectors, but it's not. Right? We've got 2 minus 3. That's a. And we're going to times that by 3. Minus 2 timesing by these. So we're just going to do 3 times 2 is 6. And 3 times minus 3 is minus 9. And then minus 2 times 5 is minus 10. Minus 2 times minus 7 is positive 14. So I've got 6 take away 10, which is minus 4. And I've got minus 9 add 14, which is positive 5. And that's it. It's just doing your substitution, but you're doing it twice. The diagram shows a right angle triangle and a quarter circle. Okay, so it's always good. We have a look at these things and we put information onto the diagram. So because it tells me it's a circle, a quarter circle, I already know that this side and this side are the same length. It's got angle ABC equals 90. Okay, so that's already on there. The quarter circle has centre C and radius CB. Okay. Work out the area of the quarter circle. Give your answer to 3 significant figures. Okay, so I know to find the area of the quarter circle, I'm going to need to do pi r squared, which means I need to know r. But I can see that r is part of this right angle triangle. And if I've got two lengths of a right angle triangle, I can find the third. Because Pythagoras' theorem says that the hypotenuse squared is equal to the other sides, side 1 squared plus side 2 squared. So let's see, my hypotenuse is 11. My side 1 is 7 squared, and I don't know what my side 2 is. Oh, but I do know that it's the radius, so I'm going to put radius squared. Oh, I've just seen a shortcut. I've got radius squared here and radius squared here. So I'm not going to have to do my square rooting step. I'm just going to have to do 121 take away 49 equals r squared. So 121 take away 49 is 72. So I know what r squared is now. I know the whole circle is pi r squared, so I'm going to do pi times 72 divided by 4. So again, using my calculator, gives me 56.54866677. 3 significant figures. So I'm going to count in 1, 2, 3. My answer is going to be 56.5 meters squared.